Good day, my viewers and my subscribers. Today's topic, we'll be looking at calculation of solubility product constant. So let's solve this exercise on the board. Question number 1. Analysis of a saturated solution of lead 2 iodide showed at 25 degrees Celsius that 150 ml, which is something as 150 cm cube, of the solution contained 0.0899 grams of lead 2 iodide. Calculate the solubility product constant for lead 2 iodide. So this is the relative molecular mass for lead and iodine. Okay, so writing the equilibrium equation for lead 2 iodide and its ion in solution. Okay, solution. So look at this, what we have here. You can see that 1 mole, the mole ratio, 1 mole of this produced 1 mole, produced 2 moles of iodide ion. Okay, so look at this question. We are not given the molar concentration straight. We are not given the molar concentration, but we are given volume and mass in grams. So what I want to do, we are going to convert this gram and volume, convert it to what? To molar concentration. So let's find the molar mass, the relative molecular mass of, or molar mass of lead 2 iodide. So this is the molar mass. So how to find the molar mass? We are going to find the molar concentration of lead 2 iodide. And the formula is mass over molar mass times 1000 over volume. You can also say molar concentration is equal to mole divided by volume in dm cube. You just do your conversion. The 150 ml given to us in the equation, convert it to dm cube. So now do mass over molar mass times 1 over 0.150. You still get the same answer. So to us the mass we are given 0.0899. The molar mass 461 times 1000 over volume. Volume is 150. So you're going to be having 1.3 times 10 raised to the power minus 3. So the unit is mole per dm cube. All right. So what it means that from what we have here, it means that the molar concentration of this lead 2 iodide in this one is what? 1.3 times 10 raised to the power minus 3. This one will be the same thing. 1 times 10 raised to the power minus 3. And this one will now be 2 times 1.3 times 10 raised to the power minus 3. So concentration of, so let me just write them out. 1.3 times 10 raised to the power minus 3 mole per dm cube. So the one of, so having found the molar concentration for the species present, we are going to be writing the solubility product equation. I have done a video on how to write solubility product equation. You can watch that video. But eventually, you are seeing this video for the first time, you're watching this video for the first time, subscribe to my channel so that whatever thing I post, any video I post, you'll be the first to be notified. Like this video. What do you think about this video? Make a comment. That will be highly appreciated. Thank you so much. So the KSP, solubility constant or solubility product constant, will be the one of lead 2 iodide. We take only the one of what? Product. Because reactant is solid. Solid is assigned 1. So it does not appear in solubility product constant. Times iodide ion raised to the power of the coefficient. So KSP. So what the molar concentration of lead 2 ion is this. So 1.3 times 10 raised to the power minus 3 times the one of iodide ion is 2.6 times 10 raised to the power minus 3 squared. So by the time you square this and multiply by this, KSP for lead 2 iodide is going to be 8.79 times 10 raised to the power minus 9. So this is the value. All right. Let us look at question number 2. Analysis of a saturated solution of lead 2 tetroxyphene at a certain temperature shows that the solution contains 1.05 times 10 to the power 5 mole per dm cube of dissolved PbSO4. Calculate the solubility product at that temperature. So this question, we are only giving the molar concentration. The other one, we are giving a volume and the mass in grams. So which we converted to what? To mole per dm cube. So in this case, we're only giving mole per dm cube. So don't need to do any conversion. Alright, so we are going to be writing the equilibrium equation for this reaction. So PbSO4 dissolves slightly. So we have Pb 2 plus, so this is solid, plus sulfate ion. So all of them are 1 mole of this produce 1 mole of this, produce 1 mole of sulfate ion. So to know the concentration of this, so this one is 1.05 times 10 to the power minus 5, the same thing, the same. So let's write solubility product constant equation for this. Times SO42 minus. So it's a simple one. We're going to substitute this concentration into it. So 1.05 times 10 raised to the power minus 5 times 1.05 times 10 raised to the power minus 5. So when you multiply this, you'll be having, what if your lecturer or your teacher wants to put units for all of them? So it's a simple one. You just do unit analysis. So look at this. Since you are giving concentration, this one is this mole. Of course, your unit will be, the unit, if you have to put unit, it will be m squared for this, if you have to assign put unit. Okay. So just do your unit analysis. So mole per dm cube times mole per dm cube. So according to the law of indices, so this mole times this mole, we're having a mole square. So minus 3. I'm going to love indices. I'm going to add this minus 3 plus minus 3. You'll be having dm cube raised to the power minus 6. So this will be the unit. If you're going to put unit, you do unit analysis. The other one will do mole per dm cube, and the other one is square. Mole per dm cube square. The other one will do it. So when this, of course, if you analyze this one, this square of this, open this bracket, having mole square and dm cube raised to the power 3 times 2 is 6. So mole per dm cube. So when you have this 1 plus 2, you have mole raised to the power 3 dm cube raised to the power minus 9 for the first one that I solved. So anytime you expect to put this, you expected, you are asking the equation to put units. You just do unit analysis. But if you're not expected to put unit, just leave it like that. So let's go to another question. Question number 3. Analysis of a saturated silver chromate showed that the concentration of a chromate ion in the saturated solution is 2.67 times 10 to the power minus 5 mole per dm cube. Calculate the solubility product constant of silver chromate. So I'm going to start by writing the equilibrium equation for the silver salt and its ion in solution. So this is the solid. So you have silver ion and chromate ion. So of course, I have 2 atoms of silver here. You put 2 to balance it. So 1 mole of this produce 1 mole of this. Produce 2 moles of silver ion and 1 mole of chromate ion. So what it means that 2.67 times 10 to the power minus 5 mole per dm cube of chromate ion. So 2.67 times 10 to the power minus 5. So this one is 1 mole and the silver chromate is 1 mole. So it will be the same thing. 2.67 times 10 to the power minus 5. So what should be the mole for this? 2 times 2 times 2.67 times 10 raised to the power minus 5 will be giving us 5.34 times 10 raised to the power minus 5. So I'm going to write this solubility product constant equation. So we have Ag ion raised to the power of the coefficient 2 times chromate ion CrO4. Oh, so this is 2 minus. So having written that, we're going to substitute this value into this equation. So KSP. So what's the concentration of a silver ion? 5.34 times 10 raised to the power minus 5 raised to the power 2 times 2.67 times 10 raised to the power minus 5. So when you spread this and multiply by this value, so KSP for silver chromate will be 1.9 times 10 raised to the power minus 14. Right. So we've come to the end of today's lesson. Don't forget to like and share this video.